All right, welcome back to the fifth installment of rational functions, where we're going to be dividing some polynomials. Let's get on into it. All right, so there are several different ways to divide polynomials. And you're just going to sort of learn that depending on the situation, you use a different method. Sometimes it's very straightforward, sometimes there's factoring, sometimes there's long division. Oh yes, long division, we'll get there. So different techniques for different situations. All right, so dividing polynomials. So first way, make a fraction, simplify it. So we start off with this polynomial here that is 2x squared plus 16x. Okay, pretty. It's a nice quadratic. And then we're going to divide by 2x. Okay, so just turn it into a fraction. There it is in my broken up. All right, 2x squared plus 16x over 2x. It's a fraction. Now you can factor. Factoring's fun. Both of these have 2x that you can pull out. So we pull out our 2x and we're left with x plus 8. And now you have a 2x in your numerator and a 2x in your denominator, and it turns into simply x plus 8. Of course, let's not forget, if this were an expression, these are excluded values and their x could not be 0. But just to simplify and divide these polynomials and not worry about their graphs or anything, you did it, you divided. Okay. Here we have dividing by each term. This was nice, this first one, because we could factor it. This one, we're not quite so lucky. All right. You have b squared plus 12b minus 14 divided by 3b. So great. If you can't factor, if factoring doesn't help, I mean, I guess we could go over here and try and factor it. I mean, we could always try. Let's just try. It's always good to try, right? We try factoring it. We have some negative 14 and adds to 12. Okay, so multiplies 7 and 2, 14 and negative 1. This one is not factorable. So factoring doesn't help because this is wah. It doesn't have any whole number factors. It's not easy. So what we can do instead is we turn it into a fraction, and then we just take every individual term and multiply it or divide it by the denominator. Okay, so it's just like Oprah, like you get divided by 3b, and you get divided by 3b, and you get divided by 3b. Everybody gets divided by 3b. So here's our b squared term. You can see in red, b squared divided by 3b. And here's our 12b term, 12b over 3b, negative 14 over 3b. Okay, fun. Notice I turned negative 14 into minus 14 over 3b. Big brain. All right, cancel those b's. Cancel those b's. There's only one left. There's none down here. It's just b over 3 is what's left. 12 and 3 cancel into 4, and the b's are gone, and so it's just plus 4. And then we have 14 over 3b. That's not 36, it's 3b. Ugh, why do we use b? And there's, I mean, 14 over 3b. I'm not sure what's missing over here. Oh yes, it's the 3. So we have b over 3, nothing gets canceled here, right? And this is missing, it's 3. 4b plus 3, that's 4, 14 over 3. This is as close as you can get, right? This hot mess here is your answer. Joy. Yay. All right. It's all right. Just because it looks like a hot mess doesn't mean you're wrong. All right. Let's scooch down and look at some more stuff. Let's try some of these. Okay. So, do red and red. All right. So we have 3q cubed minus 6q divided by 3q. Turn it into a fraction. We're using the turn it into a fraction method. We've got 3q cubed minus 6q over 3q. This can be factored up here, so why don't we go ahead and do that? We can factor this into, I'm going to pull out your 3 and your q, which leaves you with q squared minus 2. Okay, if you're not sure how I factored that, you can always multiply it back in to see if you're correct. That would make that 3q cubed, yep. Multiply that back in, that'd be minus 6q, yep, we're right, okay. Over 3q. Check it out. Now we get to cancel, whee! And we're left with q squared minus 2 as our answer. Ta-da! It's not a difference of squares, makes me sad. All right, over here, we've got this big thing over 2x squared. So I'm gonna try and factor it first. Ooh, it's got like a leading coefficient and everything. Let's try and factor it. So what we have to do is we have to do 4 times negative 12, so negative 36. And then we have to have, oh wait, that's not even gonna work. This is a 5th degree. I didn't even look, I just assumed it was a quadratic. So this isn't even gonna work, is it? Nope. So we're just gonna have to do each piece at a time. So we're gonna write this as not one fraction, but we're gonna write this as 3 separate fractions with subtraction signs in between. So we have 4x to the 5th over 2x squared minus 5x squared over 2x squared minus 2x squared over, oh, that's not 2x squared, I'm sorry, 12 over 2x squared over 2x squared. Okay, every single term, you get a 2x squared, and you get a 2x squared, and you get a 2x squared. In my class, they like to say that the distributive property only works to the left for division. All right, so now let's cancel. I'm gonna change my color, because why not? That would be gone, and this would turn into a 2. This would be gone, and this would have 3 x's left, so it would be x to the 3rd minus 5 and 2 don't cancel, but their x squareds go away, and well, the 2 goes away at least, and we're left with a 6. So our final answer, messy as it is first term doesn't even have a fraction on it. Look at that. Don't even need a fraction because that went away. That became 1, right? So it's going to be 2x cubed. And then you're going to have minus 5 over 2 minus 6 over x squared. Now, normally we would, that's not a 6, goodness gracious. What am I doing here? 6 over x squared. Normally you would put this term in front of this term. If you're putting it in, your final form for your teacher, you're probably going to want to do this. Minus 6 over x squared minus 5 over 2. Okay? And that big long expression is the answer. Oh well. Sometimes it just looks messy, but doesn't mean it's wrong. All right, let's move on down here. Move on down. All right, now we're going to divide by some binomials, not just by monomials. Factoring. Womp womp. I don't say womp womp. I love factoring, so I shouldn't womp womp that. All right, so divided by, we turned it into a fraction, so we're still turning it into a fraction. It's a binomial divided by a binomial. Turn it into a fraction. H plus 6, fitting right on there. Okay, so now we need to factor h squared plus 9x plus 18. Okay, let's make our little thingy. It's got to multiply to 18 and it's got to add to 9. So let's see, 3 and 6, right? So 3 and 6, yep, they multiply to 18 and they add up to 9. So it's going to be h plus 3 and h plus 6. Oh, look at that. Those just cancel right out, and you're left with h plus 3 as your answer. That's an H, I swear. It's an H. All right, no big deal. We kind of did this before. I mean, actually we did do this before. We did do this in a previous video. It's just that it's a horizontal layout instead of a vertical layout. You've literally already done this before if you've watched my other videos. All right, clear the drawings. Let's go down to the next thing. My favorite, long division. I'm kidding when I say it's my favorite. It used to make me cry in 4th grade, but yes, in this case, I actually do like it. It works for polynomials. What? Okay, so just because a lot of people I know in algebra haven't seen long division in a long time, let's go up here just a smidgen and let's do some revision of how we do long division. So let's say you have 5 going into my favorite number, 2,465. All right, so we know it's going to go in evenly because I like you. Maybe let's make it meaner and make it 24,652. Basics, you divide. You say how many times does 5 go into 2? Okay, it doesn't. How many times does it go into 24? That's your divide, and then you multiply, right? So 5 goes into 24 only 4 times. You multiply 5 times 4, it's 20. You subtract, divide, multiply, subtract, and we got 4. Bring it down. 5 goes into 46, and so on. You keep repeating. You divide it into the bottom of this. 5 goes into 46. 9 times, it's 45. You subtract, there's a 1, bring down the 5. 15 goes in 3 times. Yay, 15, we're done, except that I put a 2 on there, so 5 goes into 2 0 times, and then we're left with a fraction at the end. There's a remainder of 2, and the way we're going to show remainders in this long division is the same way I'm going to show you the remainder for the polynomial long division, the same way I'm going to show it to you here. You take this 2 and you say, well, you would say how many times does 5 go into 2? That's the same thing as saying it's 2 divided by 5. So it's 4,930 and 2 divided by 5, or 2/5. Okay, it's a mixed number. We're going to use the same thing. We're going to, when we do polynomial long division, we're going to have remainders, and we're going to put the remainder in the numerator of the fraction, and we're going to put the divisor in the denominator of the fraction, even though that divisor is polynomial. I know, like I said, it's going to look like a hot mess, but it actually works really well. I'm going to clear all drawings, and we're going to scooch down and give this a shot, okay? So y squared plus 4y plus 12 divided by y plus 3. Okay, you literally set it up, if you're looking here, just the same way you would is if it were like a regular pair of numbers. Okay, so y squared, blah, blah, blah. You have to now think, wait a minute, this is where your brain starts to break. Y plus 3 goes into this how many times? I don't know. That's why you do not focus on the entire polynomial. All you need to focus on is how many times, or how do I get the y to look like a y squared? What would I do to a y to make it look like a y squared? How do I turn a y into a y squared? You just look at those first terms, okay? Don't care about what's in the back. Who cares? Don't care. Well, to turn a y into a y squared, I multiply it by y. Okay, y. So you're gonna go ahead and put your y up here. Notice where I've placed it. I haven't placed it above the y squared, I've placed it above the y. We're keeping place value in a weird way because this here is all the y terms. This is the column for all your y squareds and so on, all right? So according to the order of the monomial, you know, you're gonna keep it lined up that way, all right? So the y goes up here. Now, just like in long division, you've divided, you multiply. You do y times, and I'm gonna clear drawings real quick. You do this y times this, right? Y times y is y squared. Y times 3 is 3y. Now, I'm going to need to subtract this. divide, multiply, subtract, then bring it down. We're subtracting. Now, when we're subtracting, it's really important to remember that if I have an expression that looks like this and it's subtracting y squared plus 3y, see how I put the parentheses on that? That means that you need to distribute this negative sign to both of those, all right? It becomes negative y and it becomes negative 3y, all right? That's how I like to think about it. There are other people who might like to say, oh yeah, I know that I'm subtracting 4y minus 3y. I know that I'm minus positive 3y. Just be careful, okay? If you can think like that, go ahead. I like to say, change the signs and combine. Okay, you're gonna change the signs and combine. So in this case, I wanna undo changing my signs and combine. It's kind of a shortcut for what you're doing. You're actually distributing the negative so that you can combine, or you're subtracting a positive, it's the same. Change my signs, so it would have been positive y squared, now it's negative, and this is now minus 3y. Okay, it's negative 3y. It is. All right, 4y minus 3y is y squared minus y squared is 0. Now we've subtracted, now we bring down the 12. Now we have an all new expression right here, y plus 12. Okay, so what do you have to do to y? What do you multiply to y to get it to be y? 1. What do you multiply to this first term here to get it to be the same as this first term here? You multiply by 1, and sure enough, you're just going to put plus 1 right there. Then you do 1 times y plus 3. 1 times y plus 3 is y plus 3. Change your signs and combine. So you're going to subtract y, and you're going to subtract a 3. Okay, 12 minus 3 is 9. Y minus y is y, and you're left with a 9. Cool. That 9 turns into your remainder. Okay, it's going to be 9 over the entire divisor. So it's going to be, and it's positive, so it's going to be plus 9 over y plus 3. And you can see it down here, all of this. All right, that's how you write your remainder. If this were negative 9, it would be minus 9 over y plus 3. All right, I know that's kind of a lot to take in visually at first. It's sort of the same way that long division is painful to fourth graders who learn it for the first time. It's kind of painful when you switch it over into polynomials as well, but it's the same exact procedure, just focusing on the first terms of each one. We're going to do some of this together. Don't worry, we're going to practice this. All right, so let's practice. Here we go. We're going to worry about this one last. All right, let's practice. Let's do the red one first. All right, so we've got x plus 5 going into, I'll give myself more room there, 3x squared minus 9x minus 15. Okay, so I'm going to think to myself, just look at the first terms. What do I have to do to x to turn it into 3x squared? What do I have to do to x to turn it into 3x squared? Okay, well, I would have to multiply it times 3x, right? Yes, I would, because x times 3x is 3x squared. So I'm going to put my 3x right here, because it's lined up with our x's, right? 3x times x plus 5. 3x times x is, of course, 3x squared. 3x times 5 is 15x. Okay, now this would be like that. Now we're going to subtract it. So to subtract it, we distribute the negative sign through, and these both become negative. Okay, another way to look at this is plus 15. Another way to look at this is if you said, okay, I'm taking this whole thing and subtracting it, then you'd have to remember it's minus positive 15. Okay, to me, that is a little bit trickier. I'd rather just say, oh, I'm changing my signs to negative and negative. Okay, I've distributed that negative sign through, and now we're just going to combine. Okay, let's combine. So these, of course, become 0, and now we have negative 9 plus negative 15. What fun. So we've got x, and it's negative. Let you think about it for a second, because if you're trying to do 15 minus 9, you're not on the right track. All right, so is that where you guys were? Hopefully. I always take a minute on those because a lot of times when you combine negatives, you forget that it has to be absolute value bigger, right? And then we're going to bring down our negative 15. Okay, so now I'm thinking to myself, what do I do when I've got x, and I don't want to look at 3x squared anymore. I want to look at negative 24x. How do I turn an x into a negative 24x? Well, I multiply it by negative 24, right? So I multiply it by negative 24. And now we have the fun task of doing this. So negative 24 times x is negative 24x. Negative 24 times 5. Yeah, it would be 121, I believe. No. Nope. It is not. 24 times 5. Here we go. 120, not 121. I don't know why I was putting the 1 in there. I was trying to do a fancy way in my head and I didn't subtract enough. All right, so there you go. 24x minus 120. Remember, we are now going to subtract this. Don't forget, just because it has a subtraction sign on it doesn't mean you don't have to subtract it. And when you subtract a negative, it turns positive. So like I like to say, change your signs and combine. Negative 24x and positive 24x is 0. Negative 15. Oh God, subtraction. Anybody who knows me knows I do not do subtraction in my head. I didn't do multiplication in my head a minute ago. All right, so 120 minus 15. How many of you tried to put a 5 down there already, forgetting to do this? All right, 105. Oh God, I should have done that in my head. That's terrible. What can I say? My brain doesn't like subtraction. All right, so there's the 105. There's nothing else to bring down. And so it's positive, so we know it's plus, and we're gonna make a handy little fraction out of it. It's just gonna be 105 over x plus 5. Whew. Okay, that is our answer right there. That's our answer. It is kind of messy, I know. I didn't like the way I boxed that, but that's our answer. Kind of messy. Oh well, that's the way it works. Let's do the blue one. All right, so we got n minus 2 going into n squared plus 6n plus 2. And we're going to think to ourselves, all right, what do I have to do to n to turn it into n squared? Remember, we're just looking at the first terms while we do this, okay? And the answer is I have to multiply it by n. So I'll put my n here. N times n is n squared. N times negative 2 is negative 2n. All right, change my signs and combine because I'm subtracting, so I have to change my signs to combine them. This becomes 0, this becomes 8n. Bring down my 2, plus 2. Now I'm thinking to myself, all right, how do I get my n to turn into 8n? And the answer is you multiply by 8, so add 8. Again, notice I'm keeping my n lined up with my other n terms. I'm keeping my 8 lined up with my constants, okay? 8 times n is 8n. 8 times negative 2 is negative 16. But since we're subtracting, we change our signs to combine. And then 18 over here, and that's 0. So nothing else to bring down. We have 18 left over. It is positive, so we're going to add it, make it into 18 divided by n minus 2. See how it kind of gets faster as you go through? The procedure just kind of becomes a little more rote, and it works out. All right, that's our answer. Now, finally, we're gonna look at the green one, because the green one skips like an amplitude. I don't know, the word is escaping me right now. It goes straight from cubed to the power of 1. It goes from the power of 3 to the power of 1. And that's going to mess you up if you try and do this without adding in a 0c squared. Okay, it's going to mess you up because you're not going to be able to combine the terms underneath it. You have to be able to combine like terms, and this allows you to do that. I'm going to show you what I mean right now. We're going to put c minus 1 going into, I'm going to do it without it once so you can see how it messes you up. C cubed minus 5c minus 6. Okay, and I'm going to go, okay, c into c cubed. Well, what we have to do is we have to do c squared, right? C squared times that makes that c cubed, and then c squared times 1, negative 1 equals negative c squared. And then we're going to combine, so we change our signs, and wait a minute, hold up. See how we have we're trying to combine a negative 5c and a positive c squared. No, it messes up the rhythm of it, right? It messes it up. You can't do that. Those are not like terms. So that's why you have to insert this. You have to insert 0c squared. I know that looks like OC squared. It's a terrible choice of font on my part. All right, so I'm going to erase, and we're going to try again. Erase all this junk here. And we're going to try again. Okay. Now, c cubed, let me actually do it in the right color here. C cubed plus, whoops, 0c squared. Now we can go down to the power of 1, 5c to the power of 1 minus 6. Okay, now it's going to work out. C goes into c cubed, c squared times. See how now it's lined up with the c squared row? This is why I was being finicky about it before. This becomes c cubed, c squared times negative 1, negative c squared. Change our signs to combine, and suddenly we have 0c squared plus c squared is just c squared, and then we bring down our plus 5c. Now we're rolling. What do we have to do to c to turn it into c squared? Well, you multiply it by c. Keep that over the same column. C times c is c squared, and then c times negative 1, negative c. Change your signs to combine, and you have 6c. All right, bring down your minus 6, 6c minus 6. All right, c goes into 6c. Well, how many times? Well, what do you do, or what do you do to turn c into 6c? You multiply it by 6. So plus 6 over there. Okay. And then we've got, oops, sorry about that. We've got 6c. And then 6 times negative 1 is negative 6. Change our signs to combine, and would you look at that? It goes in perfectly. We don't have any remainders to mess with. All right, because all of these are 0. Great, so that's our answer. All right, so moral of the story, there are different ways to divide. You can set it up as a fraction and factor. If you can't factor, you can use long division. If you're using long division, make sure that you are going down incrementally by powers. So if you have cubed, then the next one you need is squared. You might have to put a 0 in there. Okay. All right. So I think that is our lesson for today. Let me clear my drawings. Stop my sharing my screen. I think we're done. And yeah, yep, that's the sign. When I roll into the page assignments, that's the sign. Next time, we will go even deeper. All right. Stop recording.